This is the Robert Judat podcast, engineered with research, refined by LLMs, validated by humans. Accuracy drives it. Stay curious.
While everyone's obsessing over which AI model is smartest, the companies actually succeeding with AI have figured out something completely different. It's not about the brain, it's about the nervous system. Today, we're diving into Palantir's AIP architecture, specifically how they've cracked the code on secure model orchestration, policy-guarded agents, and real-time operational data integration. By the end of this episode, you'll understand why enterprise AI success has almost nothing to do with having the best models and everything to do with building the right operational framework. Let me bring in someone who's been tracking this space closely to break down what makes AIP's approach so fundamentally different from what most companies are trying to build.
Right. So here's what's fascinating. According to Palantir's own documentation, we're now in what they call a paradigm of commodity cognition. Frontier models have become increasingly similar in performance on key benchmarks.
Wait, commodity cognition? So you're saying GPT, Claude, Gemini, they're all basically the same now?
Essentially, yes. The real complexity isn't in picking the smartest model anymore. It's in ensuring stable performance across heterogeneous workloads that can dramatically change in scope. That's where AIP's architecture becomes crucial.
So while everyone else is in an arms race for the best AI, Palantir is building the infrastructure to actually use AI reliably in production.
Exactly. And their approach is built around 12 core architectural capabilities. The first one is secure LLM integration and access. They provide scalable access to commercial and open source models through regionally dispersed model hubs.
Regionally dispersed, that sounds like they're thinking about compliance and data sovereignty from day one.
Absolutely. Their infrastructure ensures that no transmitted data is retained by third-party providers, and no transmitted data is used for retraining by model providers. It's a shared security model with enforced encryption of all data at rest and in transit.
That's huge for enterprises. But what about the actual decision-making? How do they turn AI capabilities into operational value?
This is where the ontology system comes in, and it's really the heart of everything. The ontology is designed to represent the complex, interconnected decisions of an enterprise, not simply the data.
Okay, break that down for me. What does that actually look like in practice?
Think about it this way. An airline might model flights, aircraft, crew manifests, scheduling optimizers into their ontology to power day-of-flight operations. A hospital system models patients, nurse schedules, medical supplies, bed capacities.
So it's not just storing data, it's modeling how decisions actually get made in that organization.
Exactly. The ontology models decisions through what they call fourfold integration: data, logic, action, and security. The data objects are the nouns, but they must be complemented by verbs, the actions.
Semantics paired with kinetics, I like that. But how does this actually enable AI agents to work safely in production environments?
This is where their approach to policy-guarded agents becomes really interesting. According to their recent blog post on securing agents in production, there are 5 security dimensions that are core to any delivery.
5 dimensions, walk me through those.
First is secure and resilient access to the reasoning core. Second, insulated orchestration of agent executors. Third, granular policy enforcement across all forms of memory. Fourth, governed access to multimodal tools. And fifth, real-time observability and post-hoc auditing.
That's comprehensive, but what does insulated orchestration actually mean? That sounds pretty technical.
It means the agents operate within a strictly defined graph of entities, states, and permitted transitions. The model is treated as a probabilistic component, a generator of hypotheses, but not as a source of truth.
So the AI suggests, but the system validates and controls what actually happens.
Right. And this is fundamentally different from how most companies approach AI. According to a Medium analysis, the critical element isn't the LLM itself, but the organization's operational graph, the objects, relationships, roles, and policies the agent can access.
That makes so much sense. You're essentially giving the AI a map of what it's allowed to do, rather than hoping it figures out the boundaries on its own.
Exactly. And the observability piece is crucial too. AIP provides monitoring tools for every step of AI-driven workflows, fine-grained monitoring for all data flows, logging for every action, and the ability to trace cascaded executions.
So if something goes wrong, you can actually trace back and understand what happened, rather than having this black box that made a decision.
Right. This observability extends to token consumption and resource usage too. It's end-to-end transparency, which is essential for mission-critical environments.
Speaking of mission critical, what kind of real world applications are we seeing? This can't just be theoretical.
Oh, it's definitely not theoretical. According to their client overview, they're working with Komatsu on construction and mining operations, PG&E on wildfire support, General Mills on supply chain automation, and even the Army's first AI-defined vehicle called Titan.
Wait, the Army has an AI defined vehicle? That sounds like something out of science fiction.
It's real. And think about what that requires. You need AI that can make split-second decisions in life or death situations, but with absolute reliability and auditability. That's exactly what this architecture enables.
That's incredible. But let's bring this back to something more relatable. How does this apply to regular businesses?
Take General Mills, they're using it for complex supply chain processes. Or the New York Stock Exchange for automated market analysis. These are environments where you need AI to make real decisions with real consequences, not just generate text.
And the key difference is that these decisions are happening within a governed framework, not just hoping the AI does the right thing.
Exactly. And here's what's really interesting. AIP supports all modalities of data integration. Batch, streaming, real-time replication via CDC across any runtime like Spark, Flink, Data Fusion, Polars.
So it's not just about the AI models, it's about connecting to every data source and system the organization actually uses.
Right. And this is where their approach to real-time operational data integration becomes crucial. The ontology can query billions of objects and orchestrate tens of thousands of actions while continuously incorporating feedback-based learning.
Billions of objects, tens of thousands of actions, those are massive scales. How do they maintain performance and security at that level?
Through what they call context engineering, equipping developers with no-code, low-code, and pro-code tools for integrating contextual data, logic, and action while adhering to security, governance, and provenance tracking guarantees.
So they're not forcing everyone to become expert programmers to use this system.
Exactly. And according to their 2026 release notes, they've been continuously adding new model integrations, Gemini 3.5 Flash, Grok 4.3, Claude Opus 4.7, but the models just plug into this existing orchestration framework.
So as new models come out, organizations don't have to rebuild their entire AI infrastructure. They just swap in the new model.
Right. And there's something else really important here. Access to LLMs can be controlled based on enterprise organization, user group, geographic availability, or categorical policies set by administrators.
So you can have different AI capabilities for different parts of your organization based on their needs and security clearance.
Exactly. And according to recent partnership announcements, companies like Rackspace are now offering to run AIP in private cloud and sovereign data centers for regulated industries.
That's huge for industries like healthcare or finance, where data can't leave certain jurisdictions.
Right. Rackspace's CEO said organizations need AI that works in production, not just in demos. And their partnership aims to deploy AI use cases in weeks or months versus months or years.
Weeks versus years, that's a massive difference in time to value.
And it's possible because of this architectural approach. Instead of building everything from scratch, you're plugging into a proven framework that already handles security, governance, and observability.
You know what strikes me about all this? It feels like we're seeing the maturation of enterprise AI from experimental tools to actual operational infrastructure.
That's exactly right. According to industry analysis, enterprises now view Palantir not merely as a technology stack, but as an AI operating system that unifies data, analytics, and intelligent workflows.
An AI operating system, that's a powerful way to think about it. Like how we don't think about the underlying hardware when we use our phones, we just expect the apps to work.
Exactly. And the key insight is that the LLM ceases to be a magical center and instead becomes a controlled module within a rigorously designed architecture where decisions are reproducible, explainable, and auditable.
That's such an important shift, moving from AI as magic to AI as engineering.
Right. And what makes this possible is treating AI agents not as autonomous entities, but as operational actors that must work within strictly defined organizational graphs of permitted transitions.
So when you step back from all this technical detail, here's what really matters. We're seeing the emergence of enterprise AI that actually works in the real world.
Exactly. And the companies that succeed won't be the ones with the best AI models. They'll be the ones with the best AI orchestration, the ability to securely integrate models into operational decision-making at scale.
It's like the difference between having a really smart consultant and having a really smart consultant who actually understands your business, follows your rules, and can take action on your behalf.
That's a perfect analogy. And with policy-guarded agents and real-time operational data integration, you get both the intelligence and the governance framework to actually trust that consultant with important decisions.
Which brings us back to where we started. While everyone else is obsessing over which AI model is smartest, the real winners are building the nervous system that lets AI actually work in production.
And that nervous system, the secure orchestration, the policy guards, the real-time data integration, that's what turns experimental AI into operational advantage.
Thanks for joining us on Copilot Podcasts. The next time someone asks you about enterprise AI, remember, it's not about having the smartest AI, it's about building the smartest system around your AI.